interesting, important and easy problem of complex number. Here we solve. The first problem is two complex number Z1 and Z2 are such that mod of Z1 this is equal to mod of Z2 and amplitude of Z1 and amplitude of Z2 differ by pi. Prove that Z1 plus Z2 this is equal to 0. Here also for the second problem mod are equal but amplitude of Z1 plus amplitude of Z2 this is given by 0. We have to prove that Z1 this is equal to 1 by Z2. These two are the problem. Now here we consider Z1 and Z2 in polar form of complex number. Okay, for both the problem, let Z1 this is equal to R1 into cos theta 1 plus I sin theta 1. This is the first complex number, and Z2 this is equal to R2 into cos theta 2 plus I sin theta 2. Okay, and for the first complex number this is mod Z1 equal to R1. For the second this is mod Z2 this is equal to R2. And from the given condition for both the problem, since mod Z1 this is equal to mod Z2, so we get R1 this is equal to R2. Okay, now here for the first problem, amplitude of Z1 this is equal to theta 1 and amplitude of Z2 this is equal to theta 2. So we get from the condition amplitude of Z1 and amplitude of Z2 it's differ by pi for the first problem. So we first solve the first problem, then we discuss about the second. Now we get theta 2 minus theta 1 this is equal to pi, and we may be taken as theta 1 minus theta 2 this is equal to pi. So we get theta 2 this is equal to pi plus theta 1. Okay, now from Z2 we can write this is R1 because R2 is equal to R1, we already proved, and we put theta 2 is equal to pi plus theta 1. Okay, so we get cos of pi plus theta 1 plus I sin pi plus theta 1. Okay, and we know that R1 this is cos of pi plus theta 1. So this angle is lies on the third quadrant. The highest third quadrant, and this is the quadrant of all sin tan. So sin and cos both are negative. So we get minus cos theta 1 minus I sin theta 1. Okay, so we get this is minus R1 into cos theta 1 plus I sin theta 1, and this is nothing but this is equal to Z1. Okay, so we get Z2 this is equal to minus Z1, and we get the first proof this gives Z1 plus Z2 this is equal to 0. So this is the proof of 1, right? Now we go to the second problem. Here also mod Z1 this is equal to mod Z2, so we get the same proof here. Now amplitude of Z1 plus amplitude of Z2 this is equal to 0. So we get from the second problem theta 1 plus theta 2 this is equal to 0. So we get theta 2 this is equal to minus theta 1, and we put this value of theta 2 and this value of R2 in Z2. So as in the problem 1 we get Z2 this is equal to R1 into cos of this is minus theta 1 and plus I sin of minus theta 1. Okay, we put theta 2 this is equal to minus theta 1 and we put R2 this is equal to R1 in Z2, right? This is, and we get the value this is R1 into cos of theta 1 minus I sin theta 1, right? And now since we get this is R1 means this, R1 means this, we can write this term as this is R1 by cos theta 1 plus I sin theta 1 using de Moivre's theorem, because we know that cos theta plus I sin theta, this is equal to 1 by cos theta minus I sin theta. Okay, and to get here z1, we multiply numerator and denominator by r1. Okay, so we get here r1 and this is r1 into r1, and now we get the result as z2, this is equal to r1 square by this is z1. Okay, and this is given by z2, this is equal to mod z1 square by z1. Okay, but in our proof this is given that z1, this is equal to 1 by z2, so we can write this result as z1, this is equal to mod z1 square by z2, or we can write mod z2 square by z2, because mod z1 square, this is equal to mod z2. And if we want to prove this result, then I think there will be a misinformation. This result or this information be like, this is mod z1, this is equal to mod z2, this is equal to 1. Then we get the result as z1, this is equal to 1 by z2. Okay, and this is the proof. Okay, I think the problem is something wrong. This must be 1, or modulus of this complex number must be 1, and this complete the total solution of 2 important problem of complex number. Right? Thank you for watching.